Então, para mim, vou trabalhar, vou colaborar com o Sim, eu sou. Posso.
Hello, Mr. Yemifa. Good morning, sir.
Yes, so good morning.
How you
How
there,
you
sir?
doing? I'm good, I'm good. How you doing as well?
I'm okay. Happy weekend.
Yes, so same to you.
Now it is only two
Okay,
of us. Let me share my problem with you, please, before other people
proceed,
start joining.
proceed.
My problem is assignment. How do I get the links for assignment? I chatted you on Discord, but you didn't reply
I
me.
I've sent it to you.
I have not
I
seen.
replied to your Discord. Check your DM. I replied you in your DM. I even replied you on the channel.
I have not seen it. I will check now.
Yeah, I replied you, no problem.
I don't
But wait,
mind. You want to comport my WhatsApp, or where will I be getting that?
have you been receiving emails before? Or this have
I've
you been
not been
receiving
receiving
emails?
email for. I received the first one. Since then, I've not been receiving the assignment and other things. I don't know how you are sending it.
Ah, okay. You know what?
No,
there's
sir.
this our Google group. Let me send you the link to this Google group. So sign up. You can sign up, join the Google group, and if you still, we will send an email after this, this this afternoon. Once you're done with this session, we'll send an email. So if you don't get that email, like after I will indicate once the email has been sent. So I will try to indicate, or if I don't
Okay.
indicate, probably
Please.
later by night or this evening, Sha, can just ask him. Do you get? So if you
Okay.
still don't,
I know I
if you
complained
still don't,
about this link last. This is the third
Thi-
time I'm complaining about this link now. So
okay,
it made my this thing not prompt.
sorry. You know what? Join this Google group stuff. Join. Let's see how that
Oh,
goes.
okay.
So
I will
after,
do that.
have I sent this link to you before? Wow.
Let me
Okay, it
join the group.
seems okay. Join. You should be. If once you're in that group, if you still don't get emails, then so probably we'll get your email again, and then we'll see. We'll probably add this manual.
Okay. Thank you, sir.
All right, no problem. So how was the week, everybody? Izu, Precious, Ndubuisi.
Izu, my brother from another mother, how are you doing today?
I think both of you are in the same group.
He's my brother from another mother.
I mean for project. I thought I saw you guys.
Yes, we are together.
Yeah, my bro, how you doing now? How's it
I'm
going
good.
now?
And
Yeah,
you, let us
yes, yes.
bobo Yemife before he starts to bobo us this morning.
I'm good. I'm good.
Mr.
It's been
Yemife,
fine.
if you answer this incorrectly, what is a non-linear? Let me start with you this morning, sir.
What happened?
I
Does
have question for you.
anybody?
If you answer correctly, I will give you $1.
Okay, what do you have for me?
Let Izu ask you the question.
Okay, so I mean, I'm not asking a question. I just want to make a statement. But I know I know many on the call. But does anybody share my sentiments? Mr. Yomife, he reminds me of um, that skit maker, that popular skit maker, Lawal, that lawyer. I don't know if anybody
Oh, life.
Lai, Lai, yes. You remind me of Lai. I swear to God, I'm not lying. You remind me of him.
What was what was the resemblance?
Your mannerism, the way the way you just your mannerism, basically. Yes, I remember him immediately. I see you. In fact, thank God now I can see him as I'm seeing you now. So yeah, but I'm just saying, man. I'm just saying. Anyways,
Oh,
as for the week that just passed, the videos were the best. The videos are the best. For this week, I can so I can see that stage Imadi just joined in. So I was hoping I could say this when in her absence, right? So um the videos for this week are the best, and allow me take my time saying it. In my own opinion, after watching these videos, I'm just making my own suggestion. Maybe I'm speaking for myself, right? And I'm not trying to be rude too. I'm very polite. I feel like she should remake the videos for algebra and and the linear models. She should remake them because the her approach to the non-linear modeling was insane. A lot of things that you miss from those other videos, like they were covered here. I like how she did not separate the research, mathematics, statistics from machine learning. Like how you put it all together. Like in many other places, when you're taking YouTube courses, data camp, all of that, everybody, you're going to learn machine learning, and everybody's telling you, oh, you don't need this, you don't need this. So you go everywhere, and everywhere you go, they've told you you don't need it. So it's like, where will I learn it if everybody's saying you don't need it? So like here in her videos, I really liked it. And I struggle to watch the other ones. I won't lie to you. I'm being honest. Like I said, I'm not being rude. I'm being just objective. I struggle to watch the other videos. Um, but this one, there was no struggle. Like I watched the 1 hour. I watched the video for the not the lab video. I watched the proper video 1 hour straight. Took a break, had work to do. Came back in the evening. Watched the remaining 30 minutes. Then, without like hesitation, I picked up the lab video to watched it straight all through, and it was interesting. It was very enlightening. It's like the most and like maybe you should do video like a YouTube promo for that particular video. Yeah, it will probably get more views. It was very enlightening. I liked the whole I learned a lot. Even the stuff that I didn't learn, I went to research. So yeah, it was cool. The video was cool. I'm excited to discuss about these things today, in fact, and I know that you too, you do justice to it too. So, like last weekend, yeah, I know. So I'm excited for today's class. Yeah, yeah, nice one.
Thanks for the feedback. Thanks so much. And Teju is an OG. It's not easy to be. Teju understands this thing as at a very, very low level because it is a field. She's a PhD student, so it's not easy to be. For you to be a PhD student, that means definitely you know your onion. So it's not. It's not just. It's not just by. It's not just by chance, actually. It's something, and she has been, apart from even being a PhD student, she has been teaching this. These no, these are nice quotes, and she has been doing this since like 2017. So teaching it over time and over time, it's really, I think it's really made her know. So definitely, even me, I cannot the way I'm going to explain stuff, I cannot explain it the way she will explain it because the knowledge is there and it's really an accumulation of knowledge. So even like I'm not saying because she's here, but definitely I'll say because even though she's here, I'll say definitely. Who am I? But so, and for that, I think Teju was. You want to say something? I thought Teju was to speak. Teju, I thought you want to say something. Oh, I don't know if it's my network. So yeah,
Yeah, so I wanted to ask something too. Like, is there after this after this cohort, like after this this program is done for this year, is there like a next phase? Is there like a next level for like people that want to just be in a machine learning community? And also, yeah, there are two questions. Is there like a next phase? Do you have something more advanced, or is there just a space where we can be working on projects and continuously learning? That's one. Then number two, is there like a program that you guys do that can help people like maybe graduates from your program, like publish papers, like write publish papers and all of that? Because in doing this proposal, like the proposal that
mhm.
Tim Benokri did, we saw two papers that were very very basic, and they were published. Like I'm wondering, and one of them they got the data set from Kaggle, and I'm like, can't we do this too? Because I really want to go into machine learning, not necessarily for the money. I do this for the love. I'm not going to lie. I'm very old school. I do so I don't mind having papers out there, even though I might not have like a master's. I don't mind doing group work and contributing to papers out there. So does AI Saturday Lagos have that kind of opportunity? Like, first of all, two, the first one is, a space for people who have gone through the program to continuously like advance in this field, and then also opportunity to like publish a paper or something like that. Yeah, thank you.
I think Teja should answer the question. Okay.
Sorry, can you all hear me now?
Yes, we can hear you. Welcome.
Well, sorry about that. There's some challenges with internet. First of all, Zundo, you gassed me up real well. I was like, after your comments, my shoulder was like this. It's like, how will I bring it down now? So, but I just wanted to say that I'm really glad that you found those lectures quite inspiring and knowledgeable. And I was looking at the video again, the lab video, because I told you if I was going to make a guest appearance today to chat with everyone, and I was like, oh, what is it that I taught then? Let's see if maybe I made some mistakes, and then I can teach those part better in this class. And I was like, well, actually, it was a really nice class. So, so maybe I will just ask you, maybe we can watch it together again in this class. So, but anyway, but the whole point is that like different approach, different ways of learning. I'm happy to go over the materials, like just answer the questions that you may have. But for real, I did watch the decision trees again before this class, literally, and like that was like maybe an hour before now, and I was very very inspired by how Yeti also approached teaching the class. Yeti is my boss, for disclaimer. I've known her for many years. She's been running this, like, she was running AI classes before I even started. Like back then in 2017, she was like the lead for women in machine learning and data science in Nigeria. And that was how I got introduced to the AI community. And before we started AI Saturdays Lagos and so on. So she's really a great tutor. And it's such an honor to have her on the cohorts to teach in cohort 8. And I can say the same for all of the lecturers that you saw. Honestly, none of them are newbies. So they've been teaching for quite some time and made many guest appearances, and such an honor to have that. And like Yomfe said, the thing I have is that because I've been part of the cohort many years now, I see how different approaches have happened and how to teach, and I'm very very passionate about teaching also. So it's like the kind of tools I leverage when I'm teaching might be different from other instructor. But I love cohort 8 lectures because it gives you such a diverse perspective, and which is nice. But yeah, so I just wanted to mention that as well. But I take your feedback, Zundo. It's really great. And we'll continue to make all of the lectures better, and maybe in the next few, like, there's a plan to maybe do another series, like, which maybe me, Kenichi, and Femi can run like an entire series. But that would come. We would let you know. And to your question around what's next, that this is how I understood it. Really, we do have a way for you to continue to be involved and to continue to shine, right? So we've run cohorts based on research in the past, and it's gonna make a comeback again. But even before we start the research cohorts, if you're interested in research and you have an idea, I'm always happy to support, to mentor in that way. As you know, I'm a researcher, and I do know a thing or two about publishing papers, and a thing or two about like how to guide people, like from my perspective, or like what the reviewers is looking for, because I also review for conferences as well. So there's nothing really the publishing is not like, I know that if you're not in there, it feels like, oh my God, this is not something that I could go into. But I'm glad that you already saw that some of the work that you've done in the for the reports, it's a stepping stone, and there is a reason why all of those questions and those templates was made, because to start doing things, you need to put yourself in a position where like you want to write a proposal. What does it mean to write a proposal? And we could have just said that yeah, you're doing a project. You should all form groups, make the projects, and then we have a final presentation. But no, I wanted you to be able to like think about this project and draft it as like I would have to do if I was writing a paper. There are like sections, there's introduction, there's literature review, there's methodology, there's results, and then there's discussion and conclusion. And this is like the templates you have as a researcher. So you have to think about, what's the story I want to tell? That's your motivation. Like your abstract is like a little bit of everything that you've done. So the moment you start to think in that way, from being like a project proposal, where like you've not even started the project and you're just looking at different ways in which other people have done it to do literature review, then you get into the habit of how researchers think about it. And when I read the Benny Okre proposal, I saw it come through, and I was very, very proud. I was like, like, wow, this is quite nice. Like, I mean, I saw the thoughtfulness and the proposal, and I was like, yeah, I'm glad we decided to to stick with that format again this year. So I'm looking forward to reading all of the other proposals. It's I always see AS of today's Lagos as a way for everyone to explore and to explore their creativity, because it's all about you and we're here to support you, and you can get so many tools from the people around you to improve yourself. And you're Uzundu, you're already thinking about, what if we want to expand this to become like a research project or something? You now have a team, because we have 5 people. You can expand on the work a little bit more, a little ideas come together. You run these ideas, you experiment, and then you write it up and you put it on archive, or you submit to like a workshop if it's a smaller paper that you've written, and then you expand that and it becomes like a fuller paper. And that's this iterative work that helps you improve. And once you have one research paper, if you're interested in academia, it makes it easier for you to be able to talk to an advisor, because they'll ask you, so what have you worked on? And it's like, okay, I have this idea that came together as this. This was the motivation. This is the problem statement from that we identified, and this was the solution result that we got. And you can find and you can read more about it here. So it just helps you build your profile. Yeah. So to answer your question, we do have a way to support people within AIS at the Lagos there. If you want to embark on this research journey, let me know. I already see the proposal you have. If you have other proposals, you can send it to me. If it is not my domain of expertise, chances are I know someone who is, and then I can reach out to them to pitch the idea to them. And researchers love to work with people that are very passionate, because it's a lot of experimentation. So if someone really is interested in it, you can be like second or third author, guiding them and giving them the tools that they may not have known about. And it's a win-win situation. You're not the one running all of the experiments, but you're like on this adversary role and helping them see what they're missing, and they are willing to do the work. So that's one way to form this research collaboration between like a more experienced researcher and new coming researchers. So I think another one you talked about is Yeah, and that was mostly, but I also wanted to mention that are there like other courses that we're thinking about as a community? Yes, so our main cohort for the year actually was not is not this, but I'm really glad we're doing this because then we got to revisit the course. It's 8 lectures, but it's a build up, right? Because we are overdue for an intermediate cohort. We've been doing a lot of beginner based cohorts the past 2 years now. So next we need to run intermediate. We used to run that also in the past. So we would do a beginner, intermediate, then we'll do research cohorts and just alternate in that way. But the cohorts that we're planning, which I hope would be sometimes at the end of the year, depending on how the year is looking and the schedule and the calendar and the costs that I'm looking to use would be something around like deep learning based model, like transformers, large language model. I had the privilege of working with a team earlier this year to co-develop that course, and it's set to be released later in the year. So if everything works out well, I would like to teach that course with the community. So it's gonna be like I'm mostly going to look for tutors as well. So I'm going to reach out to many of you here who have gone through the cohort that I know that you've been very consistent to ask if you would be interested in also becoming a tutor when the time comes. But that's like the plan for the community. But I'll let you know. But next year we will probably most likely run another research cohort because Endeavor is happening next year in Nigeria, and I want us to have a bunch of research paper from within the community. And the best way to do that is to run a cohort because then people come up with ideas, and then we can use that opportunity to supervise, get a bunch of people who are researchers and doctors within the teaching team to mentor and to spend some time with the scholars. So maybe we can see like try to see before the Endeavor publications track goes out to see how much time we may need to flesh out a project. So, but that's like something that to think about for the next year. Oh, yeah. I hope that kind of like gives you an overview about what's going on within the community and the plans for the next few months, years.
Yes,
Thanks so
yes.
much for
Thank
the
you so
detail.
much. Thank you so much. Thank you so much. I really appreciate it. Thank you.
Thanks so much for the detailed breakdown. It is, it is stage yourself. All right. Okay. So I think without further ado, I don't know why we're a bit like the attendance is a bit low today. But that's how it goes. Is it because of projects or because of the assessments? Okay. Okay. So welcome to week 7 of AI Saturday Lagos Machine Learning cohort, flipped cohort 9. So this is this is a week 7 community session, and it's time just like yesterday we started week 0 and we're already at week 7 today. We have officially 3 more community sessions for this course to end. Thanks so much thank you all for sticking by us. We know it has been challenging, and yeah, thanks for ruggeding through the the mathematical jargon, through the learning new things, and it's been a stretch. Thanks for committing to it. Thank you, thank you. So yeah, let's go into we'll be doing a recap of week 7's lecture. And yeah, as Teju said earlier, she will also be like she'll be giving us a guest lecture today. Since she taught this course, she'll also be teaching us. She'll also be like, not like she won't be teaching on this, she'll be, she'll just be briefing traits because she already taught it. So she's going to ask us questions based on what you already learned. And who knows, dollar bill might rain today.
If they will pay, if they
So
will pay dollar today. Hallelujah.
I don't know.
I'm waiting for the
That is not up
question.
to me.
I'm waiting for the question.
That is not up to me, but you never can tell. So make sure you are prepared, Mhm. So okay, okay, let's just like let's just briefly go into the post today. So okay, from the submission, we noticed that it's only one team that has submitted their proposal. What I released one proposal. I released the poll. It's only a team that has submitted their proposal. What's what's the issue with others? What's the issue with others? Do you want to talk? Is there anything you want to talk about? Many people do talk on the. Some people reached out to me that their team members were like unresponsive. So I was like, they should tag them on the group so that we'll know them. But the people wasn't that even reached out to me, like I haven't tagged them on the group so that we'll know those that have been unresponsive. Just want to know the thing that haven't started. Is there a specific reason? And those that haven't submitted, okay, they haven't submitted, we're almost done. Those that haven't started, what is the what is the issue? Are you not getting feedback from your team members or what's it? Do you want to talk about it? I guess not. So is there anything from our end that we can fix? Is there anything we can do from our end? Or everything is within control? Why am I not getting any feedback? Sorry, we can talk. It's not a military regime. Okay. I guess we should move on.
I'm sorry for interrupting you, but you see that is not a military regime that you just said now. These are the things that make you similar to like. I'm so sorry.
I don't know. Probably I don't know. We might have had, similar background, but I don't watch him that much to the extent of copying his mannerism. But regardless, I don't know. Thank you. So let me end that. Okay, I guess. Okay, I hope everybody already has group members. If you don't have group member and you're on this call, can you let us know? I released the poll. Since everyone fulfills the poll, okay. So people that don't have team members are not on the call. So everyone on this call has a team member. Okay, good. I will assume that since nobody is saying anything else. Okay. Then for the week now, how many of us watched this week's video? Just want to know. How many of us watched this week's video? You watched all three. You didn't watch one. You didn't watch two. Two left. The person with two left, is there a reason? Do you want to share the reason, or is there something we can do about it, or we should proceed? Only 3 persons have okay. Okay, let's end the poll. Thanks so much everyone for participating in the poll. Well, I guess we all have 2 members, and as nobody's sharing any challenge there, so I'm guessing by tomorrow, right? Tomorrow is deadline. I guess by tomorrow, everything would have submitted their proposal. Is that correct? Is that correct? I'm assuming that, right? No, I am believing that. Not, I'm not even assuming, I am believing that. Okay. All right. So, let's now into today's topic. Okay. This was but this was Teju's opening slide, and I really loved it. So, okay, since most of us watched the what kind of model would fit this data best? Anyone you can feel free to unmute yourself. What kind of model would fit this data best? Ah, if it is raining dollar bill, no, if it's eventually raining dollar bill, I okay.
A non-linear model, yeah, like a non-linear
Why
model.
why non-linear? Why
Um,
do you just not?
because the relationship looks like it's a curve. It looks like it's like curvilinear rather than linear. It doesn't look like it follows a straight line.
Okay, thank you very much. So okay. All right, I like that. So this looking at this okay. It doesn't this is a particular line that can fit this model. This is a very it's not this is a very good line. This is a very good line of best fits that generalizes well across the data without overfitting. So if we through if it's just a linear model, it will draw a straight line. But what about at this part where it is not just a straight line, where it is not just like a flat line, where it's not just a flat line? That means the error here will be very, very much. Is our model will be performing woefully at this point. It will be performing woefully. It will only be performing probably at this point, probably this point, and probably at this point. But at every other point, it will be performing woefully. So this is why we can. So this is just telling us that this is just to show us that not everything can be fit by a linear model. But you can always, whatever you are doing, always try a linear model before moving into other things. When you try a linear model and then you understand the shortcomings of the linear model, that will now, that will inform what should be done next. Okay. Last week, let's just do a brief recap of what we did last week. We did linear regression. So okay, can anyone tell me? Okay, can anyone just tell me what they understand by linear regression? What do you understand by linear regression? Can I just tell?
Like linear regression is like a way of representing the relationship between variables using a straight line. Basically, the y equals to mx plus c line. You know.
Okay. And what can anyone tell me what this W stands for? What it represents? What exactly it means?
So W would be like the coefficient of the predictor variable, like the gradient or slope or weight. Like how the value represents how important it
Okay.
is the independent variable is for predicting the y variable.
Yeah, I wanted to hear that specific that I want specifically I want to hear that importance that it's this W tells us like the kind of importance or the kind of importance or attention like the model should give this our x. So this W is called our weight. So which is it? So we went about this before, and each feature will have a different weight. So each weight just tells us for each feature, okay, pay much attention to this, pay lesser attention to this, and like that. So in linear regression, we are just assuming there's a linear relationship between our our variable, and our target. So just that if you draw a straight line, it will like match it perfectly. That's one thing, that's one assumption. And yeah, while drawing line of best fit, you can say so there are different lines you can draw, but there's always a singular line of best fit that we can draw. Like in linear regression, there's a single line of best fit you can draw. Where you draw the line of best fit, when you are while drawing the line of best fit, what are the things you should consider? What should your line of best fit do? While drawing a
You
line of best fit, okay.
minimize the cost function, like
Mm-hmm.
minimize the that's the overall errors, that's the distance, the line that is
Okay. I missed you a bit, but I get that. It seems it's only that's on call today as well. Okay, and like, sorry, is it my network or is it? I think is it my network that's breaking? Can you all hear me clearly?
the individual
Um,
data points, but all of
Yes, we can.
the whole.
Yes, we can. It's not your network.
okay. Okay. Is it okay? It's not my network, right?
Yes, we can also not
Okay.
hear him.
Okay. I wanted to be sure if it's from my end. All right. Thank you. Thanks for that. Okay. Okay. So thanks so much, Susan, but we couldn't hear you. We're breaking at some point. Does anybody else wants to give it a shot? I don't know. Precious has been quiet for a few weeks. Um, Samuel has not been, showing up. Not like showing up, but has not been active. Precious, do you want to give it a shot?
Good morning.
Good
Um,
morning.
I think line of best fit is the line that is close, that all the points on the graph is closer to. Like the line, it can either be in between and evenly distributing the points on the graph.
Mm-hmm. Okay. Thank you for that. So this thing, okay, thanks for that. This thing, line of base should be line that actually gives you the lowest, should be the line that gives you the lowest cost function, the one that gives you like that, like when you calculate your mean square error loss, it should be the line that gives you the least of it, the least possible in your, like, for your specific use case, like for your particular data set. Thank you for that. So so and here is a sample. I'm not saying this is a definitive, but here is a sample. It is at proximity to all the data points, not just a specific one. It's able to, like, we call this generalize. It's able to generalize to all the data points. So, and here is our mean square error. And anybody who wants the mean square error, and so anybody who just wants to explain what they understand by mean square error. It's already here, I know, but do you want to talk? Do you just want to say how you understand it?
Hello.
Okay.
Hello?
Yeah.
Can you hear me?
Yeah, I can.
Yeah, sorry, my network was acting up, so I had to change my location. Sorry.
No problem.
So error basically is error itself is the difference between a prediction and the actual value, and then squared error
Mm-hmm.
is like the square of that difference.
Mm-hmm. Mm-hmm. Yeah, thank you. So that is squared error. But for a specific data set now, you don't just since it's we are not just considering 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 a particular data points. We are considering all the data points. So we take the difference of each of the data points, the actual point and then the predicted point. We take their difference, and then we take their difference, we square them, sum them up together, and find their mean. So that's not just for a single data point, but for all the data points in the particular data set. So that is the mean square error loss. So okay, now anybody wants to tell me what they understand by gradient descent? This is just a brief stuff before we go into today's point, before we go into today's lecture, please. But these are very, very important background knowledge that will always come up. So I just wanted to be sure we understood these concepts before we go into today's topic. What do you understand by this term gradient descent? Does anybody want to give it a shot aside Zunju? Do we understand these concepts at all? Does anybody care to tell me what might be the issue? Do we understand these concepts at all? Or should I call names? Okay, Taufik Olawoye, do you want to speak?
Okay. Yeah.
Uh,
I go.
okay, hello.
So I think graded descent is basically like a gradual what's it called parameter adjustment to minimize errors in a ML model, in an ML model generally.
Okay. Thank you very much. Okay, and do you want to try to explain what exactly is going on in the diagram on the screen?
So yeah, okay. The first aspect, I think, the first prediction or the first learning step was this first, can I see the random guess that the model first made. Then it had a learning step, took a learning step to try to minimize the error, like the error between the actual, what's it called? It's actually the initial value and its desired output or desired value. So it's taking step like it's learning rate like step by step to minimize the error till it gets to the desired point, something like that.
Okay, thank you very much. Please, I just want to, is it like we don't do we is it like we don't understand this concept, or what exactly is the issue? Thanks so much, Abdul. I really appreciate that. But does anybody care to does anyone just wants to tell us what exactly is wrong? Do we need to re-explain these aspects, or what? Or are we just feeling shy? You can okay, you can drop a text if you don't want to unmute yourself. Ah, okay, I'll proceed with the class regardless then. Okay, so gradient descent. Thanks to Abishaka for that. Gradient descent is an algorithm used to reduce the cost function. It's used to reduce error in our machine learning model. So from as I said last week, this the weight which depicts the importance that the model should give each of our features. These weights are initialized randomly. So it can start as from any random value. It can start from this point, it can start from here. But what gradient descent does is that, so when it starts from there, so you now say, okay, where am I? And then, okay, I am currently here. Where am I going? I am coming down. So what does it, so it decides to now be taking little steps in the direction of where it is going, which is the direction of the global minimum. So that's what gradient descent does. It helps us to reduce the error. It's an algorithm used to reduce error. Do we get that? So, and this learning rate now, this learning step, which is also learning rate, is the number of steps it is taking to come to the minimum point. So last week, we also showed us an image of what happens when you take too much steps and what happens when you take too small steps. Can I put it to us again to try to just give us a brief explanation of that part? Does anybody wants to try to explain what happens when you take a large step and when you take a small step down the slope?
Yeah. I think when you take a large step, you can easily miss the local, what's it called, the global minimum and fall into local minimum also. And then when you take a smaller step, it can take you a long time to actually get the global minimum, or you might not even probably get to the global minimum.
You were on point. Thanks. I really appreciate you, Abisha. But thanks so much for this. Thanks so much for muting your mic to talk. And thanks to Zundo that has been, that has been my partner here. Thanks so much, Abisha. So, and thanks to others that happens, that happens unmute their mic, but will unmute their mic. So this is what happens when you take a large learning rate. The thing is, it might never converge because it will keep, it will just keep moving haphazardly. It won't know when it is. It won't know like, okay, am I close there? Am I not? Why? Because it's taking a large step. So it can go. It will be going in different directions. So it won't converge. It might even never converge if your learning rate is too high. So, and this is the global minimum. If you are taking a step too small, mm, you can this is the local minimum, this is the global minimum, this is the minimum. You can have in real life you can have as many local minimum as possible, but if your learning rate is not high enough, it will be stuck here in this local minimum. Look, Abishako, if you look at this now, you see that this one is moving faster. There is no look. If it gets to if you are taking a large step and you are in this particular stuff, it will jump here. It will move. There's no way it can be stuck in this local minimum. It will not be stuck. Though it won't be stuck in the local minimum, at the same time, it won't converge. Is that clear, Abishako?
Yes, it is.
Exactly. So it is when you are taking a small learning rate, you can just like have this picture in your head, and so that it will help you understand this and help explain it better. So it is, if you are taking a small learning rate, it can be stuck here and might not never convert, and you assume this is the best your model can do. Well, it is not. The same thing with this one. This one, you just feel like, what exactly is wrong with my model? So you need to reduce your learning rate. So then we did something about on linear classification last week. And linear classification, we didn't really have a chance to go deep into linear classification, but let's just do it. Linear classification is just basically in a line of basic. But what we are now doing is now, right now, we are not drawing a line of best fits to, so that it can take all the data points, so that it can, be in proximity to all the data points. The line of best fits we are drawing here, which is called, which is, we don't call it line of best fit, we call it decision boundary, is a line that, accurately like, separates different um different what's it called now? Different features that separates different class. So this is a decision boundary. This green line is a decision boundary. This purple one is also another decision boundary. So it's just about, well, of course, which is the correct decision, which is the most ideal decision boundary out of the two? Which is the ideal decision boundary between amongst the two?
Green one.
The green one. Yeah, thank you. Because it's accurately like separates the two classes from each other. So thank you for that. So that's basically what we are doing in the linear classification. But however, after drawing a decision boundary, okay, this green line now does everything. So okay, let me use this purple line as an example. Let us assume this purple line is our decision boundary. Exactly. So now we now say that these ones now, all these ones here. Can you all see my cursor? Can you also
Yes,
mic
yes.
also? Yeah. So this now, all these rates here, they are all these rates, they are accurately classified as what? Rate, Abby. They're into class 1. Okay, let's say if you are above the purple line, you're supposed to be red. If you are below the purple line, you're supposed to be what? Blue, right? So this red, this so these red ones now are accurately classified as red. Is that correct? These blue, these blue are misclassified as red, even though they are blue, they are classified as what? Red. There are the blues below here. They are all these blues. They are accurately classified as blue, and this red now is wrongly classified as what? Blue. So these ones that are truly classified as these reds that are truly classified as red, they are called true positive. So now okay, with respect to red now. Okay, let's assume this is a cancer. Let's assume this is we are saying cancer now. Okay, this red is cancer, this blue are non-cancer. So let's assume we are saying, okay, this red now accurately classifies as this is a cancer, and this blue is telling us that it is not cancer. So we are saying that, okay, this is true positive, this is true positive cancers. But we are saying that this blue now, they are telling them that this blue is also cancer, but it is not cancer. What do we call that? Anybody wants to guess? We have true positive, we have true negative, we have false positive, and we have false negative. So we know that this is true positive, and these blue that are below the purple that are correctly classified as blue, which is not cancer, is we can say that those ones is what? True negative. But these blue that are misclassified as red, what do we call them? Are they true positive or false negative?
False negative.
False negative. Anybody else wants to give it a shot? Okay, can you tell me the motive why you chose false negative?
Because they are actually negative, but they are wrongly classified as positive.
Okay. Okay. Thank you. Thank you. Anybody else wants to give?
Or it's actually false positive. Because they're actually classified as positive, but they are negative. So they are wrongly classified as positive.
Okay. Okay. Thank you. Anybody wants to give it a shot? Please, you are free. Thanks so much, Abishako. If people don't want to, I'm not saying you shouldn't speak up again. Don't say because I said so you shouldn't speak up. Oh, you are always free to speak up. Thanks so much, Abishako. Anybody else wants to give it a shot? Okay, so the thing is, they are wrongly classified as positive. This is wrongly classified as what? As a negative. This, even though they are negative, even though these are negative, they are classified as positive. They are positive, but they are not, but they are wrongly classified. They are positive. Like when your model classified it, it's classified it as a positive. But in reality, they are what? Negative. Do you get? Your model classified it as positive, but in the real life, it is negative. So it is a what? False positive. This one is a positive, but your model classified it as negative. So that is that it is a negative, but it's a what? False negative. Do you understand the concept behind that? Let's go to this. There's a okay. Let's go to this side. Okay, now So okay, so after you get the true positive, false positive, true negative, false negative, then we now use those values to calculate our accuracy, precision, recall, F1 score, and log loss. Oh, why is my laptop hanging? Oh, my God. Sorry, apologies. Okay. Okay, let me just drop the website, this website in the chat, because I don't know why my laptop is starting. Okay, so let me just show. So if you now want to get your accuracy, hmm? Yeah, but see what if you want to get your accuracy, you add the ones your model accurately predicted, which is what the true positive here and the true negative. You add them, divide by every other thing. That will give you your accuracy. So okay, so exactly. So in your I briefly mentioned confusion matrix. So when after drawing this your decision boundary, you can plot a confusion matrix. You can plot a confusion matrix that will the confusion matrix will now tell, okay, this is this is actual value. So look at it. It is the actual value. It is positive, and your model predicted it as positive. Those are true positive. It is it is actually positive, but your model classified it as a negative. So that means like it is a false negative. Do we understand the concept of this? Or should I come again? Do you understand that? It seems I have to be speaking to myself continuously. Okay, let me proceed. So let me drop that link in for anybody. So for anybody interested for further reading, you can access that site. So it will tell you about that is accuracy, and then precision. So it will tell you what they do and when they shine. The thing is, all of them, all of these all of these metrics, they shine at different times. So you need to understand where they shine and when to say that, okay, the perfect metric for this classification task is accuracy, is precision, is recall, or I want to use a combination of a recall and F1 score. So especially in all this maybe in a medical field that you care that you don't want you want to okay there are times that you say that, okay, this person has cancer, and eventually the doctor will say, oh, this doesn't have cancer again. It's better they say that somebody has cancer and the person does not, than you say that. And okay, and then after going for further test, we're able to like eliminate without any we're able to eliminate beyond any reasonable doubt that this person doesn't have cancer. But if someone has cancer and we say that the person doesn't have cancer, we say that that is very terminal. if the person doesn't have cancer and our model incorrectly predict that the person has cancer, we can, there will be drugs, and then there will be, the person will be washed. The person will be coming for, tests, and so that, and after watching it, that, oh, okay, oh, this was, misdiagnosed. It is better, like that kind of misdiagnosis is better than you tell someone the person doesn't have cancer, and then you are treating something else, and eventually, when you now catch the cancer, it is already, too late. It is better to catch cancer at a very early stage than that. So this, if you go through it, the model way, this picture, this blog will tell you. So yeah, that's about it. I just said I should just go through that before it. So ordinary least square. We did Teju explained this on the ordinary least square during our lecture. Does anybody wants to explain what they understand by this ordinary least square? Anybody? Okay. Ordinary least, okay, for a linear model, and for a small amount of data, if your data set is not that much and you want to plot a linear regression, you can use a formula. You can use this ordinary least square to actually like get the line of best fit without training your model multiple times. But it is only useful when you have a small data set, and you have a small data set, and you want to do linear regression, and your data set is small. So that is where you can, instead of doing gradient descent and doing it iteratively, for a small data set, you can just use ordinary least square. But if you have a large data set, it will be computational extensive, and it will be better to use gradient descent. Gradient descent is an algorithm that that you can use from simple to advanced machine learning model. But if you have a small data set, so instead of iteratively using gradient descent, you can just substitute it with ordinary least square. And you can, she explained this, you differentiate it, and you get it. That's basically what ordinary least square is. So but the criteria is that you have a small amount of data sets. Okay. Now, to creating polynomial fit. Now let's go to this. So it's after in this in the slide, while Teju was explaining this particular aspect, she was showing, okay, she was just using two features of the Nigerian Spotify playlist. She was using the energy and loud. It was using loudness and energy. She was plotting them together. So even though we can say that a a linear a linear um a linear relationship exists, but we can still create polynomial features to make it fit the line, relationship better. So basically, creating polynomial features, what it does is that, okay, you square okay, depending on the number of polynomial features you want to do. If you want to square it, if you want to, like, cube it. So if you want to square it, so that oh, I don't write the equation, but you can say that, okay, you want to square, if you have x1 and you have x2, you have y, which is equal to x1 and x2, and you want to square it. That would be x. You have x, you have x, you have x1, you have x2, and you have x1, x2. If you had, oh, I'm already talking about it. Okay, let me insert the text box. So I don't know why my laptop is lagging. I need to replace this with this one. Okay. So let's say you have if you have x1 and x2. So if you want to square and you want to if you want to if you want to square it and you want to create a polynomial feature, y will be equals to what? Mathematics students in the x1 squared x1 squared x1 squared plus x2 squared plus x1 x1 x2. Does this make any sense?
Yeah, it makes sense for fine. Yes.
Please, others, do it think does this make any sense at all? Okay, let me just instead of this x underscore, so let me just do x2. So for uniformity. Does this make any sense, please? Or I should come again?
Sorry, I'm sorry, can you come again?
Okay,
Well done.
thank you. Thank you. Thank you. Thank you, Boom. Oh, thank you, Luabum. So okay, this is a mathematical express
Function.
is a mathematical expression. Okay, yeah. So just say I want to do x. Okay, you have x, or your equation is was y equals to x1 plus x2. Y equals, you know what? Let me probably I should open polar. Why is my laptop lagging? If you have can anyone if for those that understand it, if I want to cube the x, if it is x1 and x2 and I want to cube it, what will my answer be?
I think you just have like and like extra terms for the cube. I
Right?
guess you have extra terms for the cube.
I'm looking for the best way to expand. So say, okay, let's say y equals to, okay, let's say y equals to x1 plus x2. If I am squaring it, okay, let's say I want to, okay, mathematics. Now let me say, I now want to square this. Let's say I want to square this. Square, right? Okay, so let me do okay, let me zoom in. Do we all get this? Start two, right? So what it does is, okay, it's just like, okay, that means so expand the what's it called? Expand the yeah, expand it. So let me just copy this. It just what do we call this back in mathematics then? So control V and control V, right? Are we still on the same? Are we still on the same lane?
Yeah, we are with you.
So this is x1. So you are squaring. This is x1 plus x2, x1 plus x2. That is what. So when you square, so that means you are saying that x1 there plus x2. Is that clear? So now open this. Oh, open. Sorry. That will be x1 squared plus x1 squared x2 squared plus x1 squared plus x2 squared plus x1 x2. But the two, I forgot where the two went, Sha. So do you remember? Sorry, can you help me out there? That'll be x1 squared plus
x1 x2 plus
x1 plus
x2 x1 plus x2 squared. Then there will be an addition of like terms x1 x2 x2 x1.
Thank you very much. X1, okay. Let me do it. X2. X1, x2 is the same as x2, x1. So let me just do x2, x1, n plus x2, x2 squared. So this is, oh, sorry. I run into error. Stop. To give me an error. Well, guys, let's just continue. So, so this is x1 squared plus x2 squared. But I know x1, x2. But this thing, I don't know. In the equations, what you just have x1 squared, x2 squared plus x1, x2. They don't really talk about these two, and I have forgotten the reason why. So, well, probably Teju will remember. I mean, I probably Teju will help me out there. So, but that is why we have, that was what I was trying to explain here. So that is how we got this. And then, so if you are doing the same for cube, I know. Okay. And if I want to do cube as well. So let's say I'm doing, so that will also be, okay, let's say we already know this is the output of x1. This is already the output of x2 squared, right? You can just say that. We are not teaching maths. Today. I just wanted to show us. Okay, this is x1, x2, and this. And then you expand. So exactly, so that will give you x1 cubed, x2, x1 squared, and also x. So if you expand it eventually, you can just go and try that. You can just go and try that. To give you x1, x1 cube, x1 times this, right? Plus, okay. Okay, let me just complete this.
So what's happening, Yamife, isn't that it's not being expanded the way you're thinking about it right now. So when we have two variables, right? So we have x1 and x2, and you want to build the polynomial features of these variables. You would have x1, x2, x1 squared, x2 squared. Then you would have the interaction between x1 and x2, which becomes x1 times x2. So that's how. So if you're building like it does not, even if it is like up to x5, like fifth polynomial, because there are two variables, you're also considering the interaction between the two. You can make it much more complicated to do x1 squared times x2 or x2 cubed times x1. You know what I mean? So it's not the way you're expanding it literally like this. That's how the features are being built. So it's just like, okay, you want to build like you want to build features of like with polynomial degree 3 and you only have one feature, then it's going to be x1 x1 squared x1 cube polynomial degree 3. If you want to get a 5, x1 4 x1 5. But the moment you have multiple features, so then you have to consider the interaction between these features as well.
Yeah, so basically, so not explicitly as this, exactly, not explicitly as I am, expanding it. So probably basically that's the reason why we don't really like use the two x1 x2, like when we, instead of adding this, we just want to like weigh all the interaction between all the with the different possible stuff. So if it is just, if you are squaring it, you have x1 squared, x2 squared, and the interaction between x1 and x2 itself. If it is cube, you have x1 cube, you have x2 cube, you have, so this is x1 cube. I can say that, okay, at the end here, you have something like, you also have x2 cube, you have x1 squared, x2, x1 x2 squared, and you have x2. So okay, let me complete this. Okay, so this is x1.
Can you hear me?
Yes.
Hi, I'm saying you're not wrong. Like you're expanding it's
Okay.
like you have x1, x2, x2, x1, and x2 squared. So like if you have like three times now, it's like it would be what? X1 cube, x1 squared, x1 squared and x2, then x2 squared and x1 at some point. So you can do this expansion as well to see how the degrees are being formed. Like so x1, x2, x1 squared, you have x1, x2, you have x2 squared, x3, x1 cube, then x1 squared, x2, then x1, x2 squared, then x2 cube. You can work it out the way you're doing it to see how it goes. It's a nice exercise. But
Okay. Yeah. Thank you. Thanks. Thank you. I almost thought I lost something there. Okay, so okay, are we still together? Who told me to come again earlier? I think, was it not Bumi?
Yes, I'm here. Thank you.
Okay.
Thank you.
Like, is this clearer?
Yes, it is.
So there is x1 plus x2. So apologies if it is not clear as it's supposed to be, but this is exactly how it's supposed to. So, and if you're having it to the power of 4, so you can expand it further. So I hope this is clear. So these are basic, instead we started from just x1 and x2, which is just which is just a linear interaction, but we are expanding it from the linear interaction to a polynomial interaction. So, which is how we got to this point. So that's basically linear. That's basically also that's basically how we create polynomial features. Yeah. But one thing about polynomial features, at some point, when you keep expanding it like that, you see what is our model doing here?
It's overfitting.
Exactly. It's already overfitting. It is trying to, it's trying to pick as many points as possible, which means that which is similar, which is just telling us that this stuff it has already gone beyond what we need. And if we are introducing a test set, our model will perform woefully. If you calculate the mean square error for this particular polynomial feature of 100, you see that it has a low you see that it has for the training it has lower error, but for the test the error will be higher because it just keeps learning this, and that is not the goal of machine learning. Machine learning the goal of machine learning is that your model should be able to like generalize to unseen data in the same distribution. Like it should be within the scope of your training of your original data set. Okay, let's say your trained data set now was built on a data set that is only gotten from within Lagos. Let's say okay, I showed us my proposal last week on building a machine learning algorithm for house price in Nigeria. Let's assume my data set I used to train my model now. I got that only from Lagos. But my test set is now showing data sets from Abuja and Ibadan and other places. There's no way my model will be able to like generalize to that aspect. Do we get that? That's already out of distribution. Your test set should be within the scope of the trained data set. So that is how you can actually you can truly evaluate and say that okay, from what my model learns, it can do some things. Your model learns some things and now it can actually like it can generalize. But if your test set is not something similar, you would think your model is performing fully. Meanwhile, your evaluation set is what is causing the confusion. So if your data set, if your trade set is just Lagos, then your test set should also be Lagos. Okay, Precious, proceed.
Please, I want to ask, is that why we divide our data set into testing and training?
Exactly. That's why you evaluate on that particular data set because they are within the same distribution. Those data sets were gotten under the same circumstance. Do you get? Let's say if you got a different data set on cargo now, but you feel like if you got a different data set from cargo and you train your model on that, and then you're now going to pick another data set, even though they are on the same topic. We now want to pick another data set to evaluate your model. It will not generalize because the statistical relationship between each data set is different. If you feel like you don't have enough data sets, what you can do is that combine both data sets. Combine the two different data sets you have, and then now after combining them like accordingly, but before you combine them, you need to like read through the dataset description, read through both, and ensure that they are in the same let's say the price now. The price of one is in dollar, price of one is in naira. Make sure that you convert both of them to be naira. They are in the same units. If one is in naira, the other one should be in naira as well. If or you should is it so make there is a uniformity in your data set. Do you get? So once there is uniformity, you can you combine them together. Then you can now shuffle your data sets. And then after shuffling it, you can now split it into train and test data sets. That is what, with that one, you can evaluate your training data sets. But if you are just picking the other data sets to evaluate the model that was trained on a different data set, you will not get what you are supposed to. Precious, is that clear?
Yes, understood.
Exactly. So, yeah. So you can see this is, even though we wanted our while in this polynomial feature, we wanted our models to be able to like pick as much feature, like to be able to like do the best it can to understand understand the statistical distribution within our data set. But eventually we ended up overfitting our model. So what do we do now? There's something, okay, this is also something, it's generalized. Major reason why we do build machine learning model is for it to be able to like generalize. But if it doesn't generalize, it's not, it's not, so this is still basically what we are trying to say. The higher the higher the degree of polynomials exhibited, okay, the higher degree of polynomial exhibited overfitting. If you watch this lecture, you understand that. Sergio was showing us, okay, she was showing us from 1, it was 2, 3, 4, 5, 10, even 50, and then 100. And you can see how it's progressively overfitted on our data sets. So, but we don't want that. We don't need to be able to like, generalize, but within the same scope. Remember, if you we are while Tejo was teaching, she used energy and loudness. If you use another feature, that is no longer generalization. That is another stuff on its own. Is that clear? I hope that is clear. No response again.
Okay, so I'm being mindful of time. It looks like we have less than
Okay.
30 minutes to go.
Ah.
Let me do a
Oh, wow.
quick run through, and then you can take it
Wow.
up from there. Um,
Will you share your
so
screen then?
yeah, okay, I can do that. Thank you. I am looking into your slides. You still have a couple things to cover, so I'll see where I can get to. It's fine. I think the lectures and the labs are uh, very explanatory. So if anyone goes through it, they should be able to pick it up. But I thought that I could use this time to, just go over the the concept and ask questions, And
Yeah, please do.
one of the let me look at let me get the slides on. Hi everyone, how are you doing today?
We're good. Hi, Sergio.
Okay, nice to be here with you, and amazing. We're already in week what? Was it 7? Is it 7 or 8? I've lost track of time, but it's 7.
We are in week
Uh,
7. Week 8 starts tomorrow.
okay. Wow, time flies when you're having fun. This is what they say. Or not. Anyway, thanks. It's a pleasure to be here with you. And I've been very impressed at the pace of the cohort. It's a lot condensed, as you know, but you've been doing great. So, and you should be very, very proud of yourselves. And it's not a one-time thing. You will go over the lectures again. You're using some of the concepts, but I really hope that you can make it a habit to go through the lectures before the class. I even gave you some tip. You can watch it at TX. Maybe I'm saying this. Maybe it's easier for me to do because I know a lot of the concepts and I can still follow on that. But I still think you can benefit from doing that because what happens when you go go over at that space is that you're able to get the breadth of it. You know what the instructor covered, and if you're still not understanding some concept, you can go back to watch that at the pace that you would want. So, but if you never get to the end of the course, you don't even know what are the things that were covered that you could come back to later. And what's nice about YouTube videos is that they're all time stamped. So you can also just jump to wherever you need to be. For this lecture on non-linear modeling, I was using the Spotify dataset. But I'm going to take a pause to just ask you a few questions. It's like, why do we need to think about non-linear modeling? Like, why at all? Or do we care about that? It's an open-ended question, no wrong answers. Want to get the conversation started.
Yeah, we need non-linear modeling because, like, in real life, like data, not all features or not all variables have that, like, linear relationship mathematically. So yeah.
Yeah, this is correct. Real world data does not necessarily have linear relationship. And for this reason, we need tools that help us to be able to work with the way the real world data would, like what we get. But the thing about linear modeling assumption is that it is very powerful, and it's great for a lot of use case. And the trick about even what you're learning in nonlinear modeling is that you're still making linear assumption. So we're saying nonlinear modeling, right? And you're thinking that maybe we're using some algorithm that is just it's non-linear somehow. You're like your linear regression, your y equals mx plus c, suddenly it's not useful anymore there. But no, the assumption, underlying assumption is still linear, but the interaction between your features and your target it becomes not linear. So you start to manipulate your features to introduce some non-linearity such that when you start modeling using the linear assumption, you're still able to correctly separate, find the right hyperplane or line of best fit, as we've been calling it, that correctly separates between the target variables that you care about if you are working with a classification data set, or correctly predict your continuous features if you are working with a continuous data set. So for this particular notebook, I was going through the Spotify data set to give a different use case. However, the notebook itself was inspired by this lecture from the Practical Data Science CMU group. And it's one of my favorite like open source open source lectures out there. Very complete in my opinion. And when we started using these materials from the practical data science team from CMU, it was taught by Professor Zico Porter, and it was like we even collaborated at some point. We had access to all of the assignments and the solutions. So I really feel proud to be using this for our cohort because it's a great lecture. And I'm saying this because when you look at the cohort, it's lectures that we've developed for you. It seems like it's all standalone, like different lecturers are taking different topics. But a lot of those lectures were inspired by the topics here. We designed it based on this curriculum. And so you can always come back to this particular website and this lecture as a way to expand your knowledge, to learn more. This is a university course. And if you, by the end of going through all of this and the course, its lectures, you can do the assignment, you know within yourself that you have the skills that you've been looking to build. So now we are in linear modeling. So I'm just going to go to the lecture notes, which is the lab notebook, and you can see that similar to like how I have the lectures, right? And but the data set is different intentionally. So here, the lecture is using the data sets from the Pittsburgh. What's it called? Was it the energy, the load, the temperature over the different season. What I think it's called the temp demand. Yeah, temp demand CSV. So literally, you're looking at the different the temperature, and then the peak demand when the temperature is high or low. And when you focus on this snapshot of data sets, where the temperature is between 60 degrees and 90 degrees, you observe this upward movement of the peak demand. Can everyone see my screen clearly, please?
Yes, we
Yeah,
can.
Yes.
yeah, we can see it.
Amazing. So when you look at this data, what can you infer? What kind of modeling fits this data?
I mean, non-linear. Non-linear.
But this looks like a linear relationship from my perspective, wouldn't you say?
Yeah, yeah, it looks like it, but I mean, a line. It looks like it's because they're moving in the same direction, right?
Yeah. So we could
Yeah,
potentially fit a line on it. Can I
yeah,
annotate? Let's do that. So let's fit a line. Right? It's not a straight line, right? But you
yeah.
could do this. This
Okay.
would reduce your loss, right? What was the definition we gave for linear regression again? It's the line of best fit is the line that minimizes the what?
Yeah, the cost function.
The cost function here,
Yeah,
which is the cost function is the mean squared error, right?
yes.
Between your real data set and that line. So
Yeah,
if you compute the cost function for this line, I mean maybe not this one, but a line that is reasonably like that passes through the middle of this data point, you probably can't do much better than that. You know
yeah,
what I mean? It's still reasonably okay.
yeah,
So I'll still argue that the data looks somewhat linear and you could fit a linear model. But what does this tell you? It says that if you have a modeling that looks like this, this line, it's saying that as you continue to have lower temperatures, then the peak demand should be lower, right? So
yes,
it's
yes,
if you have this linear relationship, and as you have like higher temperature, I mean, then it's higher energy you need. But like but then it changes because you zoom into real world situation, and this is what they did in this particular lecture. You started with something that looks fairly normal because you took a snapshot that it's not it sorry, it looks linear in that snapshot. But if you zoom out and look at the entire season and the recorded data set, let's see if I can remove all of this annotation, clear ordering, and yeah, you can stop now. Okay, so this is what it looks like, like for the entire season, from like zero temperature to like more than 90, because we're talking about the peak demand in Pittsburgh, it's in the United States, so sometimes the temperature goes really quite low. So you can be like 0 degrees at some point. And now, what would you say? What kind of modeling would fit this particular data set?
Definitely non-linear, because this is curvilinear. The shape
Exactly.
is
It most definitely. Exactly. This even looks like if you're very good with your curves, what kind of curve does it look like? Is it
at all. I don't. I'm not good with curves. You say I don't know what type of curve. Is it quadratic or I don't know. What we call
yeah,
this? I
yeah,
don't know.
yeah. Yeah, it's definitely what comes to my mind is quadratic as well, because degree two, because then you have like this the this shape. But then if you're thinking like degree three, then you have like this almost what's it called?
Cubic.
Sinusoidal somehow,
Okay.
cubic, you start to think. But maybe cubic could also be okay with this, but square would probably fit this quite well. I think. But anyway, sometimes I think about the shape of the like the when we're thinking about the different um uh curves or what kind of what kind of polynomial do you fit into this, and it's nice to have the image in my head as to how I think the data set is being modeled, and what kind of shape it has. In normal distribution, it's like normal, you have like this peak and then you have this tail. Then you can have that in your head. That if you see a data set that looks like that, and someone asks you, what kind of what kind of curve or like what kind of model could you fit on this? What kind of assumption can you make here? You look at the data set, it's like, oh, this look like a normal data set. So it's a Gaussian assumption would fit here. Or then if you see something else that looks more like maybe a truncated Gaussian or like I'm saying a lot of words now, but let's Google it. I like looking at it, then I'll come back to it. Um, uh, what's the word I'm looking for? Curves is not the right word. In maths. What is the correct terminology here? It's not curves. Um, I mean it's curves, but I'm trying to remember. It's harder for me to Google this. Um, okay. Oh, distribution is the word I'm looking for. Distributions. Okay. Yeah. All right. Let's see. There's so many beautiful distributions out there for the math geeks. Yes, the probability distributions. Which I believe that for the next week, it should be we will be going through probability distributions, right? Yeah, Michelle. Can
Yes, city
everyone still hear me?
distribution and yeah.
Oh,
Can you hear me?
nice. So next week is basics of
Mhm.
probability distribution. Yes, I can hear you now. Okay, great.
Yeah.
So then you would appreciate the lectures a bit more because I'm preempting it. So look at this
Mhm.
open image in new tab. Let's look at this image. So we have like these are the common distribution. So every model that you interact with machine learning has some underlying assumption. You cannot do anything without that assumption. So a lot of the machine learning models that you work with, the assumption is that the data is IID, which means it's independently and identically distributed, which also assume that it's a Gaussian by its, like, if you sample many data, in expectation, you reach a Gaussian distribution. So this is why, once you make that assumption, then a lot of this model, they have different flavors, but most of them have the same assumption. I'm saying this for people who are interested in research because the more then you start to work with different kind of data sets and you need to make assumptions. And maybe your data set is not normal distribution. Maybe the assumption that fits there should be something like an exponential, or like you're working with categorical data. If you want to model that categorical data, you're thinking about categorical distribution or binomial or Vita distribution and so on, and also uniform. So you would, in your journey in machine learning, you cannot run away from these terminologies. They're there. So it depends on which level you stay with. But this is the teaching class. I'm not afraid to talk to you about math and the probability distribution, because I know that you need to first share it somewhere, and then you start to pay attention, and then maybe when it comes up you learn a bit more, and then you can gain better intuition about it. So coming back to this particular one that I was talking about, I was thinking about what kind of um, distribution or what kind of curve could fit the data. Here it's a nonlinear relationship because it's no longer a straight line that can fit this data. And so you can see this example here, it tries to fit a straight line, and if you compute the loss here, it's going to be very high because a lot of the data is not being modeled well. And so this is now where the non-linear functions come into play. As Yomifo was explaining before, how you get to this non-linearity is just by manipulating your features. So because I'm supposed to be doing a lab, I'm going to try to get into an interactive mode to make it easier to talk. And I'm doing this because I want you to do the same thing by yourself. You go to this website or you go to my lecture notebook. I assume you've already learned everything about it. So I wanted to teach you something new or show you something new. So let's work with this notebook for now. I'm gonna go to Colab because this is what we've been encouraging you to do. So, and then I will try to upload a new notebook. Browse. So I go to this folder that I just downloaded and unzipped. You can see the nonlinear modeling notebook. And then I try to upload it. So far, are you with me? Hmm?
Yes, sure. Yeah, yes.
Yes,
Okay.
you
All right. Do you have any, do you have any questions so far?
Yeah, so my question was like about the video, the non-linear modeling, the video, sort of like
Yeah.
towards the ending of the video, where you spoke of
Is it the lab
um
or the lecture?
no, the lecture itself, yes, the lecture, yes. So my question is just
Mhm.
about, well, it's not really a question. It's just like it's a bit, the concept was a bit vague, like and that's regularization, right? The regularization.
Okay.
Um, you were talking about the penalty. You're talking about, I think, lambda. You're talking about the penalty that
Okay.
regularization introduces. Yes. In the lecture.
Yeah. Okay. Let's
So
look at the
I just,
slides.
some of it wasn't like, okay, yeah, in the in the lab video, because you spoke about it in the lecture and then in the in the lab too. So in the lab, in the lecture there was a definition you gave it. Then in the lab, you the way you used it was different because you were like I there was a way you used it in the lab, and I don't know if it's because you were writing your own functions, or but it was a bit because you multiplied it by a like an identity matrix at the time. So it was different from the way you use that's the way you use the penalty. It was different from how
Yeah.
the penalty is defined. Yeah, that's what I'm trying to say. So I don't know if you can
Okay.
throw more light on that
Okay.
part.
Let's try to find so you said like regularization, then you're talking about the particular yeah, here. Is it? Is it this lambda I? This one. I'm sorry, my internet is very poor today. Can you hear me? Can anyone hear
Yes,
me?
we can hear you. You are
Yeah.
very audible.
Okay, amazing. So are we talking about this one? Like this lambda I, the identity matrix and the lambda? Is this the
Ye-
confusion?
yes, lambda I.
Okay, and
Although it's
you
like your screen seems static though. I don't know if anybody agrees with me.
Yeah. Your screen is static. We are seeing
Yeah,
non-linear modeling
yeah, your screen is
and
static.
generalization.
okay. Uh okay. What do you see right now?
Okay.
Ah,
A pop-up was
Maybe
just
I
clearing
can,
up, and it's still the non-linear
yeah,
under the data science course on the is the data science course.
okay. Let
yeah,
me
maybe you
try
can
again.
stop
I
sharing.
think my internet is not good.
Yeah, you can stop
How about
sharing and
now?
share again.
Probably you can stop sharing and then reshare.
I just stopped sharing and reshare. I think I may have been lagging as well. But can you guys hear me? No? Am I
Yes,
lagging?
you are audible.
Okay. So what can you see?
The screen is yet to come up.
Okay.
It said you
Then
have
it's
started
really, really
sharing your
bad.
screen, but it is not yet coming up.
Mm, I see.
Am I
Let's
speaking for
try
everyone,
again.
or is that just one?
Yeah. You're speaking for everyone.
Oh,
Yes.
seriously, no. You have spoken for us.
Okay, should I share my screen? I can explain using my hi Seju. Oh, I think she left. Okay, I think she left and she probably should rejoin. Okay. All right. Let's give her a few minutes. Well, do you understand the concept of regularization, or it was just how it was used in the what's it called?
Yeah. Like I get the concept that for those exploding gradients, I get that concept,
Mhm.
but I don't understand what the term is. Is it because is lambda multiplied by something? So what is the something? The two of them together, are they the penalty together? Is lambda multiplied by that value? Do they make up the penalty together, or is the penalty just lambda? That's what I just wanted to understand.
Okay, let me try to open. I'm trying to open it up from my end as well. While we are waiting for it. So let me share my screen so that I understand the. Okay. Can you see my screen? Can you see my screen?
Yes, yes, sir. Yes, sir.
Okay. So okay. Let me go. Let me check control. Mm, um, okay. So is it I want to are we there already? Are we at that aspect or not? Or is it below it?
Yeah, yeah, I think you already passed it. Just above, like, so yes,
Okay.
yes. Above this chat or
Okay.
before this chat. Oh, yeah. Oh, so yeah, so yeah.
Hi,
Hold on, hold on,
everyone.
hold on, hold on.
Okay. Oh, all right. Okay.
Hi,
Let
everyone.
me stop. Yeah. uh, We can hear you. I've stopped sharing. Let me stop sharing so that since
Okay. Oh, but can you see my screen?
not yet. Instead you have started sharing your screen, but okay. Yes, we can.
Okay. I'm sorry about the troubles with the internet, but hopefully this is okay now. So you were talking about the lambda I, right?
Yes, yes. I was thinking about this exactly. Yeah.
And yes, and then you said that something was different from the way it's defined in the lecture. Can you?
Yeah, like the way. So I'm trying to find out, like, in regularization, I guess that you're adding a penalty term to the
Yes.
um to the sum of squared errors, right? I get that part. So I wanted to just confirm what exactly is the penalty term itself. Is the penalty term lambda multiplied by an identity matrix, like what you're doing here
So
inside of your.
the so the penalty term is a scalar. You get what I mean? So a number between, like,
Yeah,
you could
single
have like
value.
10, 100, 1,000, or what's not. So the reason why we would have this identity matrix is to be able to uh, do these matrix sum. So this X transpose X is a matrix. Do you agree?
Yes.
Then, if you want to sum, like it's this, to make it nicely, so we just have this identity matrix, which makes like it makes the penalty term comes on the diagonal, and so in order to apply this penalty on the weight that you care about, this is just
Oh,
it's
okay.
just a way to make the math work.
Yeah, make it
It's just
work.
it's
Okay,
just so
yeah.
you know you
Yeah,
you care about each of the features, which are your
yeah,
columns. So the
yeah.
penalty will be applied to the columns.
Okay, yeah, okay, true, true.
Does that make
Okay,
sense?
this makes sense. Yeah, it makes
So
so
you
much
can do the
sense now.
math. Yeah, you can try it out, and yeah.
Yeah,
Okay, so
but
this is why it's
so
there.
like, okay, I sent an image like in the chat though. I don't know if you can see the image
Uh,
I sent in the chat. So
I just
um
rejoined, so I can't see it. Can you
oh
reshare
oh
it?
oh can I leave it to, okay, let me just send it again one more time. Sorry. Uh
Okay.
uh yeah, it just came in. I don't know if you've seen it in the chat.
Okay. It's loading right now.
Okay, so
Okay, now I see it.
how, yeah, so now like in the like in this situation, like how does that apply? Like we're not converting, like, I mean, I'm just trying to, I'm trying to see how that equation is similar to this one. I'm just like, I just need, I'm just trying to understand, that's all. So like if it's something that is
Yes, yeah,
maybe,
this is a great question. Let me try to relate it. So when you let's come back to this. So the way we x transpose x is the same as the sum over from 1 to n y at the residual that you have here, which is y I minus y at squared. So literally the dot product, which is this x transpose x, can be rewritten as sum from 1 to n yi minus yi at squared.
yeah, okay,
I mean, of course, like, I mean, not squared, without squared. Like, if you wanted to square it, then it would be like x squared or something like that. So, but
mm,
let me tell you, like, if you have like, are you familiar? You're familiar with dot product, right?
yes, I'm familiar with that product.
Yeah. So, I'm coming back on my words now. So in this equation, x is the y minus y at x. Do you get what I mean? Like
Yeah,
x
I'm saying,
here, x on
yeah,
this on the way you the one I'm showing is your y I minus y at. So if you
okay,
say yi minus y at squared, so the let's come here.
okay,
It's
yeah, yeah,
better
yeah,
for
it
me to
makes sense.
write. Yeah,
Y
it's
minus
better.
y hat is the arrow, yeah, the arrow, okay, I get.
Yeah, it's the error. So we have sorry, it looks like I'm flexing my latex skills, but I guess I was um someone mentioned it earlier. So we had x transpose x, right?
Yeah, yeah,
That was what we had. And so this x transpose x, I'm saying, is the same thing as what? If you forget about this transpose, like, I mean, what is it? It's just x times x, right? It's nothing. Like, it's just
yeah,
x, which is what? Yeah. The transpose is just because we are working with like matrices of different dimension, which I won't go into, but x transpose x is literally x squared, right? But what
yeah,
you had was what? Y I minus y, you had y at, right?
yeah,
Y I at, so, and then you had square, raised to power square. This is what you had. If this is working well, arrangement, right? So you had yi at yi and square. Sorry, this wasn't range very well. This should be okay now. Let's see. Was this what you had? I'm looking at your equation. No, something is wrong. Uh,
yeah,
y
yeah, why,
hat. I think it looks like this, right? Then there
yeah,
is a
that, yeah,
square.
is a square, yes, is a square.
No, yeah,
Well,
okay.
well, no, like
Something is
what
not.
you're trying
So
to
the
do in latex is correct.
okay. But something is wrong with the heart. This is it. But maybe it's just like this is not rendering well. But let's do this for now. I think it's closer. So y high minus y hat square. I'm saying that this is the same thing as what if y I minus y hat let's just replace it. Let's say x, we're doing maths now. X equals to y have this is this, right? And then it literally comes back to what we had up there, which is like x squared. And the dot product, what the dot product does for you is you do multiplication, right? It's like for the first row, you're multiplying the first row of this first matrix with the first column of this next one. So if you look at your sum, yeah, like the sum from I to n over all your like residual y high minus y at squared would be equivalent to doing like x transpose x.
Okay.
That's what dot product does. It's an inner product. It's like sum over all the element eventually. If you're still not, if you don't agree with me, we can do an example. But I think even in that video, I tried to do an example. But do you see it? Do you see
Yeah,
the
yeah,
equivalent?
yeah. I'm seeing how this can replace that. Yes, yes, I'm seeing.
Yeah. So then now coming back to the lambda I. So here the lambda penalty is still there, but the penalty should be applied to the weight. So it's B here in your formula is the same as the parameter theta or W or whatever notation we've used in the past. And if you look at this, where was it again? Here, was it? You can see that we're like the lambda I, we're trying to penalize this we adding it to the to the dot products the inner products between the features, and because we know that the theta itself they all apply to each features, so this would have the effect of trying to like if the values are too high, like the weights are too high, it will try to reduce them. So it penalizes. It's try to have more affinity for weights that are smaller in such a way that your overall optimization is not like you're not overfitting to like bigger weight. But all of this looks very theoretical. It always makes more sense in my opinion to try to run them, and this is why the notebook is there. And you can print out stuff, like print out and look at the weight before you regularize, and the weight after you've applied the regularization.
All right. This
But
it
these
makes
are
so much
yeah,
sense.
but the equivalence is there. It takes some time to map them together. But what you have there is it's equivalent to that notation, the way you write it in that matrix form that I showed.
Yeah, it's very clear. I mean, I see how this can replace that, or you can expand it to look like that. But I want to. I mean, speaking about this, like furthermore about this, I like you because we're changing the equation, like replacing, terms in the equation. So I wanted to just ask one last question, two more questions. Sorry, the last question is, oh, sorry, the first of the two is the lambda alone is the penalty, right? That's what I just want to confirm. Lambda
Yes,
alone is the penalty. Okay,
yes,
fine. Yeah, okay, fine.
this is
Then
correct. And it
yeah,
is
then the
applied to
second,
the weights.
and this
P is the
applies to the weights. Okay,
number of weight. Yes, it's applied to
of
the
yeah,
weight.
yeah. So as many variables we
P,
have,
P so P yeah, exactly. So P here is the number of variables that you have, and N here is the number of data points
right, right, right,
in
right.
the one you shared
Um,
in the chat.
yeah, yeah. So yeah, that's perfect. So now you spoke of the B B is like the weights, right? The coefficient. So it's like the
Yeah,
M
B is
right?
It's the
Yeah,
theta,
so
it's the W, it's the M, whatever it is that people use.
yeah, so it's the M, and we've already explained the X's, right? And we can see what Y is in this equation. So like where is C, like the intercept, or is this on the assumption that like the bias is
So
zero?
yeah, for that one, it could be as it's mostly people once you write it in a matrix notation, the bias become wrapped into that matrix, and it's a nice mathematical trick. So let me show you what I mean, because I also used it in my notebook. So where the bias is, like you have, like you add additional column, and the bias would be you set all of those that additional column to 1, and that is the bias term. Because once you start to do, let's see if I can find it. Um, just a rewriting. Trying to find the shortcut now, but probably just easier for me to scroll down. Um, So when, for example, let's see, did I use it here? The energy is 1. Yes, here. Great. Amazing. Look at this. You can see that this is the X here, and these are the features, right? Energy, we were only dealing with one feature, but it's a polynomial degree 2. So we have x1 and x1 squared. And then you have this thing 1. Like, what does that mean? But if you expand the equation, it would be like theta 1, which is the parameter, like b in your case, times the x1, the first feature square, plus theta 2. This is the second parameter that regulates the second feature, times x1, right? Then you have theta 0 times 1, which is the bias. So you can see that it's encapsulated in the data matrix by making including additional column where it is all 1. You can that can be the parameter associated to that column is the bias. This is usually how the implementation, like how the implementation works in most, even most framework. But does that make sense to you?
Yeah, I get the verbal the explanation, but I think I didn't see your screen. I think your screen is static still, so I don't know.
Oh,
But I get
I'm
the
sorry.
I
What
get
are
the
you seeing right
explanation.
now?
I don't know. I
Let
can
me take a
see you on
screenshot and put
GitHub.
it in chat.
Yeah, I can see your
Okay.
GitHub. You're on GitHub now.
I'm I'm sorry, not the way I thought I would make this chat happen. But can you see my screenshot? I just put the screenshot there. Maybe that's easier. But that's the part of the notebook that shows how the bias is incorporated into
Mm,
the equation. So usually
yeah.
that X that I showed before includes the bias term.
Mm,
So it's not
all right.
just the features, it's the
It's not just
features
the
plus
features.
bias
Yeah.
term.
Bias
What
time. Okay.
yes.
Yeah.
So you just expand it by one more column so that you can learn a parameter for the bias.
Mm,
So this is how
right.
we usually do it in practice.
Right. Yeah.
Yes. Yeah. The screenshot is not coming up, but in either way, maybe that's a good time to send it back to Yomife. I just wanted to also mention something that Yomife was discussing around the expansion of the polynomial features, right? So you were asking that what happened to the two? It's supposed to be 2x1, x2, right, Yomife? Can you hear
Yeah,
me?
yeah, yeah, yeah.
So really,
Yes,
so
I
what's
can hear you.
happening
I'm
is
hearing you.
because
I'm fine.
yeah, like when we're doing that expansion, we don't need the coefficient two. We only care about the features and the relationship with the features. So if you do as you did before, the expansion with the polynomial degree three, you will see that all of the coefficients was not taken care of. Like it's supposed to be 3x something, but you don't see the three there. It the you can think of the question the coefficient literally are the things we are trying to learn from the data. So for each data will have different kind of coefficients. Those would be the theta. So the two that you see in the x square would be like equivalent to what you will end up learning as a parameter of that feature. Yeah, so that's some explanation, maybe something to when you're working it out and it's like, doesn't make sense. Why am I not seeing this? It's just it's not meant to be like an expansion like that. You're looking at the interaction between features and you're looking for parameters to learn because you're modeling in this way. So and I also wanted to apologize that this week we said Femi was going to make an appearance. We're going to set an update as to when he's going to be able to do that, but definitely maybe the next week or latest the week before we finish the lectures. And if you have any questions, I can do another check-in. I know we didn't have a lot of time to talk, but if you have questions around the lecture that I have taught, or maybe some other lecturers have taught, still don't understand something, we can do like an impromptu like question answering sessions where it's all about what does this mean? I looked at this, what do you mean by that? And then we can like, chat. Boy, thank you.
Wow. A wonderful round of applause for Teju. Thanks so much for giving us this wonderful lecture. It's not every time you get taught by a PhD student, so by a pro. So it would be a doctor in view. Let them even do PhD student. It's not every time you get taught by a doctor in view. So yeah, thanks so much for the lecture. And thanks so much. I really appreciate that. Because I was just like wondering where did the two went. Thanks for pointing that out. So does anybody have any question for Teju? Like based on this lecture? I think this is why we do like try to introduce everyone to go through the lecture before we come to the community session. Today now we had Teju on call. This is your time to shoot all the questions that you're firing up. So and I know some of us might have had challenges with the mathematical equations that were passing around in the lecture and in the lab because not everyone come from a strong mathematics background. But as Teju said on the Discord channel, if you will be going for research, everyone that is interested in AI, like I mean the core AI, not just implementing API and stuff like that. If you are actually interested in something like what Teju is doing, you will definitely require the mathematics. But if you just want to, okay, probably just be normal data scientist and or if you'll be going for masters in artificial intelligence, let me just put it that way. If you're going for masters in artificial intelligence, you're going for masters even in data science, you would need all these stuff. If you want to go for masters, but you don't feel like going for masters eventually, okay? Maybe not. But if you want to actually like progress, you want to like go as far as possible in this your career. At some point you need so it's better you are familiar with them now. So when you encounter them in the future, you kind of there's already a background knowledge you can follow upon. Even though you still like learn about it further, but at least you already like have something to build upon. And you can there's they probably you just remember, I will talk about this in here. You can just like go back and reference these lectures. Like, oh, yes, we did this, we talked about this, and it will be able to give you a better background, and then you can build on it, learn more, and you know. So yeah, so that's basically it. So please try as much as possible to understand this. As much as it is number one, understand the concept. It is very, very necessary. Understand the concepts on the underlying concept. It is very, very important. Don't just say that, okay, don't just do it. Know why you are doing what you are doing. It is very important. It makes you stand out from someone that is just doing it and you understand what you are doing and you understand why you are doing it. So it's very
And
important. Then you now
I'm sorry. Can I just mention, if you've not watched the decision tree class, I'm serious, it's a really good one. I'm not even kidding you. I do a lot of math. It's just style. It's what I'm used to. I try to explain in layman terms as well. But decision trees, you like Yeti just went through the intuition about how to build a tree, what does Gini index means, impurity. And I mentioned it earlier in this call, like I rewatched the class just like an hour before we started the community session, 2x speed, and it was quite good. Like, and I really just don't want you to miss out on it. So in case you've not done that, just watch it and just to understand the concept of this decision trees, and it would really help you because it's one of those prominent algorithms that you may end up using in your day-to-day if you're not interested in, say, research or anything. You just want to be able to build models for some data use case. I think that's a good one to also put in your toolbox. Just want to mention that as well.
thank you so much for that. And it's also, it's also like a how do I call it? It's a platform that all the random forest, there are stuff that other decision tree is a very, very basic model. You just understanding the intuition will make you understand how other algorithms perform. So it builds the foundation for all these algorithms. So you should watch it and understand. Don't worry. Even though there's not much mathematics in it, don't worry. But you shouldn't be scared of mathematics though. But there's not much mathematics in it. It's a very, very theoretical and very, very easy to understand. It's very, very easy to understand. Watch it, understand what decision tree, what she's talking about in the decision tree, and then you can now you yourself can now take it for okay. I also understand. She also talked about YGBM and XGBoost. So and you can just take it. Also, I think she didn't talk about. I'm not sure she talked about random forest. I'm not sure. Yeah, exactly. So watch it. You are muted. You are muted.
I'm sorry, she mentioned the difference of the difference between boosted decision tree and random forest, but
And
she didn't really go into it.
yeah, boosted and the other one. I forgot
I think she talked about she talked about the
light.
difference between XG boost and light GBM.
Hey, yeah,
Right?
exactly. Yeah, exactly. So please watch it and watch it. If and you can take your reading further. If you are reading stuff, even if you are reading, if you are building on this knowledge, you can always ask your questions. If I cannot answer them, surely Stage will be able to answer them. I'm not a pro. I don't,
And if that you cannot answer, we'll ask ChatGPT together,
exactly,
like
exactly.
Gemini.
We'll be able to figure out this together. So don't worry, you're in safe hands. So please, thank you so
You're
much for
always in
sticking.
safe hands. And looking forward to reading all of your what's it
Proposal.
called? Proposals. There's no get like everyone has to write that proposal. You know, if after this call, we need to start sending messages. The word, the word that comes to mind, I don't want to use it so that I don't start my Agbero self. But you need to make sure
No problem.
everyone writes a proposal and everyone submits one because it's good for
Mhm,
you. I
mhm.
I believe. And don't wait
Okay.
until you have five. You can be two people and have very quality conversation. And I'm happy to like have a chat to talk about your ideas. I sent my calendar on the Discord, just to support you as much as I can. But you need to put in some effort from your side as well, and don't be intimidated. Yeah.
Exactly. So, Teju opened up a calendar so people, this is your opportunity. Seize the opportunity, work on this thing. Like, how should I say that? You should work on this stuff, and even if whatever project you are working on, this is your opportunity to pitch your idea to you don't know, it can be an opportunity for collaboration with you never can tell, depending on your idea. So don't be overwhelmed. Just try to how would I say, try to flesh out your idea, and then even try to flesh out your idea in the way you understand it best. And then when you share it, and then we stage you some guidance, then we'll know, okay, how best do we do this thing. So please, those of you that have been wanting to talk with Sergio, those of you that have been wanting to, Sergio won't just like come and pick you wherever you are. You need to like start from somewhere. Like, this are the thing is, for you to be here, actually, you have access to Sergio. No, not just Teju. There are a lot of OGs in the community. There are a lot of OGs in the community that might not be, that they don't really show face. One of them is Miss Adesola that do come once in a, that do come. I don't know if she's on the call right now. She's a very, very, she has been an organizer for, maybe, I don't know, since probably 2018, or I don't know, before 2020. I know. Where was that?
Yeah, since 2018 now. She's
Exactly.
been one of
So
yeah.
she's a very senior person. The Mr. Kenneth that taught us the linear is an OG. And the forest part, there are a lot of people in the community that might not see. There are also masters that finished their masters in artificial intelligence. There are also some that are currently doing their PhD all over the world, in the US, in Canada, and like Sergio now in Germany. So please, and there are a lot, she also just to work on your stuff and pitch it. So I don't worry. There are a lot of resources that can go around. So, but the thing is, what you are supposed to do, she won't do it for you. So, but once you are here, there are a lot of people that can mentor you. There are a lot of people that can mentor you. So as long as you are here, there's mentorship opportunity is not scarce. But the thing is, what nobody will come and pick you for points. You need to put in your effort. Nobody will say, oh yeah, nobody will just start walking you. Nobody will hold your, not like, well, we are to hold your hands, but you need to put in your efforts. That's basically what I hope I make sense. That's all.
Yeah, and Yomi Ferros, you have access to Yomi Ferros all the time. But I think what we're trying to say in essence is that I do believe that project is an important part for you to learn, and I'm trying to push you to think about it. It's not about the certificates. I mean, it's nice. Everyone who has a of the legal certificate has done a project that we can boast about. I'm very serious about the certificates criteria intentionally, because then it means nothing if like everyone can get it. So if you're not interested in certificates, then you just want to workshop the classes, that's also okay. Because I believe that knowledge is not something that is once and it's like one and then you're done. Some people take the cohorts more than one time. There's no judgment here. I can understand. It's not easy. But as much as you can, if you are put in a position where you can dedicate some time, I think you should make use of it. Make use of this, the energy, the timeline, the fact that it has an end. Now you can almost see the end, and you can come back to yourself to say, wow, I stuck to it till the end. I think sometimes that is a nice feeling to have, but if does not happen, it's also okay, not the end of the world. You do it again, you start again. And until you get to that point where you feel yourself as knowledgeable in some domain. And collaboration goes a long way. and you never can tell. You just like go for random ideas, and then you're talking about something with someone, and they're like, so how are you thinking about X and Y? And before you know it, you're like, okay, maybe we should start this project, and you're starting this project, and it becomes some other things that you weren't really thinking about to begin with. That's why I love community as well, because you never know who you can meet. So I hope to know more about every one of you, what you're doing. And my way of knowing more about you is by looking at your proposals and trying to support you as best as I can, and then hearing how you're talking in the cohort. And that's how we become more acquainted as to your work and my work, and then we expand. Because when we run this cohort again next year, because I know you, I'm like reaching out to you. I was like, Azuntu, how are you feeling right now? What you think about like being like your me fair for next cohort? So so yeah,
Uh,
just saying.
mm-hmm. Right. Okay. Is someone wants to say something?
Yeah, yeah. Hello, can you hear me properly? Sorry.
Yeah, we can.
Yeah,
Okay, yeah. So I just wanted to like say that you spoke earlier before most of us joined the call. You said something about like Indaba happening in Nigeria, and you spoke of the
yeah,
research. You also spoke of like an intermediate level training and a research level training. So
yeah,
I wanted to, I said something earlier and I'm just saying it again, like is it possible to like indicate interest in these things ahead of time? Like I don't mind working on stuff and all of that. Like if you're doing anything, like do we have to go through your research program before we can like publish papers with you and stuff like that? And again, how flexible how flexible is it? Because like some of us, like I know some people want to like move into the space like professionally, get a job, and I understand this, but everybody's doing it for the money and all of that. But I'm just saying, like, I'm doing this because I actually like this. So is it possible? And I like what I do professionally. So is it possible that you're like, if you get to a research phase with your program, is it possible that it will be very flexible for like a working class person
yeah,
to
yeah. It's
jump on
yeah. It is
and
always flexible. You know what?
okay.
I'm really glad that you're interested, because this is something that's it's on the in the plan for like, I'm putting like we're putting together like some calls for research for some research projects, but I cannot say much right now. But I'm going to send out like maybe like a form or something before the end of the year. Because again, like I said, I want the community to have some projects to showcase at the Endeavor, and I feel like we are there yet. We usually have projects to showcase at the Endeavor. Maybe myself, my co-founder, some of the OG organizers, and so on. But we've never tried to do like this structured. We run this research cohort because we want to submit to the Endeavor. So this is something I want us to do for next year. So let me get back before the year runs out. Most definitely, it's in the plan. It's gonna happen, and then I'm looking forward to working with you. But also, I want to know what you're interested in. We don't have to wait till the end of the year. You know, have a do some survey, some literature review. Think about like what are you interested in? What's your flavor? Like what topic gets you? And just send me a few ideas, a few bullet points. Research is not rigid. I may be thinking that, oh yeah, we wait until next year, and then someone pitch an idea to me, and I know all of the tools we can use to do it in the moment, and it's like, let's see, like what conference can we target, and then let's have this meeting. It's about what kind of problems am I interested in right now? That's because everything is about the investment in time. But even if I am not interested in that problem, maybe it's something I can advise, or someone else I know can advise there, and I can just connect to say that, see, is nobody's interested in RL, but I don't think I have the skills right now. But that I look at someone from the community. I know that maybe my co-founder Femi has done some RL stuff, or like um I'm thinking about Lawrence right now, and I was like, Lawrence, what do you think about this idea? Do you have some time? Like, let's um this is how I think we can get it done. Let's set up a meeting, and we have like a structure. So sometimes it just happens like that, but it all depends on the individual. What are they interested in, and then what are they pitching? So this is like in general information to everyone. All is open, but also pressed for time. But don't take that as Teju never has time or anything. Just ping me, and I may be slow to respond, but eventually I will. And yeah, Yomife knows, also sometimes we just like have a meeting and just chat about what's going on. But sometimes I'm like, if it's quiet, not because I'm quiet, but because I'm watching him from afar. He probably doesn't know that. But then I come back to say, how's it going? What are you thinking about right now? So that's my advising. That's how I advise people. I give you time to breathe, to see that you can do things on yourself. I'm not too involved. And then I come back to check how's it going, and then we have a conversation and say, so what's the next stage? So
Yeah, okay, thanks so much for that. If anyone has any question, you can drop. If there's any further question, you can go through. You can ping on the chat. So but even though we'll not be able to like go through the rest of the slides today, but I'm not necessarily like bringing anything new this week. So you get everything this week is self-explanatory. Like they are very, very basic. If it was last week, I felt the need to, after going through this slide last week, after going through the lecture, I felt the need to like break it down a little bit further. But this week, the materials are very, very like explanatory. If you check my slide, I didn't like. There's nothing new there. Everything was just like, okay, here is my slide. You see, most of everything on this slide was based on what was taught in the class. Everything was based on what was taught in the class. So I was not bringing anything new. So please go through it. So there's no further explanation I'm trying to
Yeah,
make.
sorry. Like I'm looking at the calendar, but like there are no videos for the coming week. I don't know.
There is week 8. Yeah, I'm coming there. I'm coming there. There is. I'll show. Okay. 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 Do you mean on the calendar?
thanks, Izuto. You're correct. I will fix that.
Oh,
Yeah,
on the calendar.
yeah, on the calendar.
Yeah,
I
on the
didn't I didn't
calendar.
update the next week. I will fix that. Thank you. I missed
Okay.
it.
Okay. Yeah. Thanks for noticing that. Thanks so much. So okay. Okay. But if you go to the GitHub, our GitHub, if you go to the GitHub, where is it? What's doing this
So
network
I'm
today?
actually I'm excited about next week as well. because it's it's very mathy. But you would, yeah, I hope you have fun. So it's a probabilistic model. So you're gonna learn about basics of probability from amazing tutor who you've seen before, Emifa. Emifa is one of the tutors that I think are very good at explaining from my opinion, like from my perspective. And then the other lecture is on maximum likelihood estimation, which I gave that lecture, I think. I think I gave the lecture. So
Yeah.
it's like I was going through math, some probability distribution. But I think both lectures are just to give you some basics in probability. You cannot run away from probabilistics, like modeling or probability itself in machine learning. So it's yeah, think of this as your it's the first time you're doing it, and I want you to fall in love with it. But it's okay to take it slow if you need to be, but there's nothing scary about it. If there's a formula that doesn't make sense to you, yeah, throw it at me or we just chat about it. I hope we get to become that community of people where we look at math and we smile because we can intuitively understand what it's trying to say. Like no matter how complicated it looks, you can say by just looking at it, what is it that they're trying to do here? And the more you look at this math and the more you have more like exposure, the easier it becomes. You get to read a paper and you just look at that, it was like, okay, yeah, here they're trying to use some min-max thinking from some ideas from GAN or some ideas from this. And they're just like, because they're not really new ideas, everyone is just matching and making and then joining things, you know. But it's all the fundamentals don't change. That's the beauty of it. So once you really learn the fundamentals, you can just be flying, be king of and queen of your field. But yeah, it takes time.
Right, exactly. Right. So, she's talking from experience, not just aspiring to aspire. She's talking from, years of experience. So I think you can take her for that. So yeah, this week, so as I said, basic of probability, likelihood estimation, and naive base. So yeah, it might be a bit technical too, but please stick with it. Stick with us. Yeah, you can do it. You can do it. So please do it. Thank you. We are rooting for you. And drum rules, there will be no assessment this week. So there's no assessment this. Want everybody to catch up with everything, projects, everything. Like so, everything since there is no assessment. That doesn't mean you shouldn't watch the lectures. Please watch the lectures, but at the same time, try to if there's been anything that has been unclear, if you need to rewatch the previous videos, please do so. Whatever you feel you need to do to catch up with the class again, please do. So that's why we are leaving this week again as a break point for everybody to catch up. So please watch the materials, watch the videos, and come with your questions. We never can tell. Sergio might be, teaching us next week. So everybody wants to, we all want to get the best from, from being taught by Sergio. So please come with your questions and yeah. And the materials are very, very explanatory. Just stick with. And if there are parts that you don't understand, please communicate them to us on time. So, if a lot of people, if you find that a number of people are having issues with that particular aspect, probably something we like, it might be an oversight from our side that okay, probably an assumption that okay, people should understand this. And if you don't understand it, please let us know and communicate with us. So we'll excuse me, I had to sneeze. Sorry. So just communicate with us so that we'll prepare towards that like ahead of class. So is that clear? Please, as you are watching it, if you have questions, drop them on the chat. If we can answer them, then fine. And if we feel like it's something we'll have to answer on the call, then why not? So Yeah. As you remember, this is week 8. This is week 7, which is running off today. Week 8 starts tomorrow. And yeah. Okay. For those that don't have the calendar, here is the calendar.
Yeah,
And
so please, so is there, yeah, an assessment for like week 7? And please, where can we get that assessment? So
assessments for week 7. Who talked just now?
sorry, it's me. I don't know why. Is
Oh,
there
okay.
anything, or is it too late? I don't know.
Wait, no, it's not. Tomorrow is the deadline. But have you been receiving emails?
I haven't even though I, like, for example, the previous assessment was from a mail. Well, it was from a mail you sent after the class, but like after then I haven't received any mail.
Wow. Okay, so what can we do? Some people are saying they do. Some people are saying that it's been a while you received email. Some people are
I
saying,
have a
And I
question.
and
So
I've
I have a
and I've
question.
joined the
Did
group.
they no, did you fill the form, this form that says that join our flagship cohort? Did you fill it? Because if you fill that, everyone that filled that form should be in my mailing list. So what happens is that maybe some people joined the cohort through the AI Saturday Lagos channel, like the Google groups. And sometimes I send all of the information to the Google groups. Sometimes I don't. I only send it to people from the cohort. But if you did not fill that form, so I'm just going to open it again because that's my gold truth for everybody that is enrolled for this cohort. Does that make sense to you?
Yeah. Instead of
So
sending it to
let
everybody, just
yeah, instead of just sending to everyone,
but
who is like part of our mailing list. So so Yomife, if anyone is saying that they cannot see the emails, just ask them to fill this form. Then I will close it again later
okay,
on. But yeah.
yeah. Okay, are you opening the form now because it's closed
Yeah,
currently?
I just reopened it. So
okay,
if you feel it, then I have you in that list.
Okay,
okay. All
thank
right.
you.
I will. Okay. Okay. So okay. Yeah. Thanks so much for that, and Thanks for giving us the grace to fill this form. Okay. So I will include the form in I'll include the form in I'll include the form um uh, like in the mail that will be sent after the session. So
Okay, then I can send it to also the mailing list of yesterday Lagos to say if you are part of the cohort and I didn't fill the form, this is the last call to do it.
mhm.
We can have that messaging so people know that it's not all the time that we send email to the mailing list.
Okay. Okay. So you can
All
okay, so
right.
we should yeah, we'll talk about that. We'll talk about it.
Yeah, and
So
so I also wanted to mention that I have this book that someone gifted to the community, and I've been tasked to give it to one person or two people. So I think I have one hard copy and one soft copy. So we'll be going to select a project or one person or two people by the end of the cohort who might be interested in receiving this book from one of the community members. Her name is Dani Eriyo. She wrote a book on business success with business intelligence. And there's a soft copy, which another member of the community bought on behalf of people from the community. But I have been tasked with giving it out. So if you win this hard copy, I'll find a way to send it to you somehow, get it to you at some point in the future. But if you win the soft copy, then it's easier. Just get your email address. Just want to say that there's a book to be won. But the way we receive it, I think it's just be like Yomife is going to select a top 2 or 3 people by the end of the cohort, and then we would give the gift.
Okay. All power. All right. So yeah, thanks so much, everyone. Thanks so much. Thanks so much, everyone, for sticking with us to week 7. Yeah, enjoy. So please do what to you can check. There's nothing new in the slides actually. They are all from the lecture. The slide I couldn't go about. They are all from the lecture. So I'm not saying anything new. So please go through it and let us know if you have any questions, you are free to ask them and let us know whatever challenges you have. This week as well, watch the videos. If you're having any challenges, reach out to us. We'll try as much as possible to answer you. Don't worry, we are here for you. So, thanks so much, everyone.
Okay, sorry,
Um,
sorry. So, sorry, please. Are you still going to send the mail with the assessment link or how?
the mail.
Yeah. So,
Okay. Yeah,
or
okay.
you can
Yeah,
share a
I
link.
will.
If you can share a
I
Yeah,
will
we
link.
can
send. I
do
will.
like the recap email for today could maybe include the assessment, but like we can also share the link now, if you
Okay.
want.
I think I did that. I
Uh,
did that last week as well. Well, can
Yeah,
I
yeah.
think you
Last week.
can.
Yeah, you did it last week.
Uh,
It was fine.
Are you on the Discord channel?
Yeah, I'm on the Discord channel. Yeah.
Yeah, I think someone asked for it and I pasted it I
Yeah.
think was it this morning? You can
Okay,
check.
I'll check. I'll check there.
assessment.
Yeah,
I'll,
yeah, I think it was this morning.
yeah,
6:12. I
but
posted it by 6:12.
it has coming though. Yeah.
Okay.
Samuel
Thanks.
Ikete, this is not your first cohort, right, Samuel? Is this your first cohort? I feel like I know that name. I've seen it before.
This okay.
Samuel,
I'm friends with the co-founder.
Femi.
Yes, yes.
I only have one co-founder, but I just needed to say it out loud. Okay.
Yeah, yeah,
Yeah.
yes, yes, yes.
Yeah,
Um,
okay, amazing.
uh,
Yeah,
That's great.
he was my senior in University of Ibadan. He was 2 to 3 years above me. So,
oh,
Ah,
yeah, yes.
Femi's
wow.
great. I'm looking forward to inviting him on the cohort. It's one of those charismatic speaker. You would love him straight away. So, yeah. But hopefully in the next week or in 2 weeks' time, it would be able to join and uh like grace us with his audience.
Mhm. Thanks so much for
All
joining
right.
us.
Thanks everyone.
Yeah, yeah,
Bye.
thanks so much.
I'm almost feeling sentimental about this cohort ending too. So felt like we just started and now it's like almost
Exactly,
the
and now
end.
it's almost ending.
Yeah, okay.
Exactly.
No worries. But we still have like 3 weeks to work on the project. We have decided to extend the project by like the project, what's it called again? The presentation is no longer October 18th because we've been told that that is the Dev Fest weekend and
Data
we
first.
support I said Dev Fest. I'm sorry. The Dev
Data
Fest
first.
weekend. So we will try to hold it the week after, which will be October 25. But we'll send an email. So you're going to have 3 weeks, literally 3 weeks to work on your project and perfect it. So let's make the most out of it. That means you also have 3 weeks to catch up on all the lectures. And if you're nice to Yomi Fair,
Exactly.
maybe it's going to extend the assessment. I don't know. If
Exactly.
you're nice to
So isn't
him,
it?
I don't know. Uh,
Yeah, I think it depends on if there are a number of people that needs it to be extended, then we can do that. But if not, we'll close it by yeah by tomorrow. By tomorrow, and then for other assessments to just if you have any issues regarding previous assessments that has been closed, reach out to us. Let us know whatever it is. Thanks so much, everyone. Thanks for waiting till now. Sorry we took a bit of your time. Wow, this is already 1 o'clock. Wow. All right. Thanks so much, everyone. Have a wonderful week. Yeah. Bye for now.
Bye.
Bye.